Okay, bonjour, good morning. This is Asfan speaking, and today I came with another exercise about, exercise of HMS hack data preparation for another catchment, for another big catchment in South Africa, that is Vaal Catchment. This is the Vaal Catchment. This is South Africa, my country, big country. And Vaal is one of important catchment of South Africa. Last time I did Tukala catchment. That is Tukala. Let me show Tukala catchment. I think if I can. Yes, that is it. Yes, let me make it more colorful so that it will be visible. But this is to color. So um, now another big catchment, that is Vaal. This is to color. You can see color. It's just um, a catchment next to it. Another basin. Yes. So I think they share the same mountain ridge, I think, so that um, some part of the water goes to Kala and the other to Vaal, and then finally flow to Orange River. Uh, this Vaal River is a very long river. It's around 1,200 kilometer. I mean, without considering all the tributaries. I mean, if it can go up to 1,500 or something like that, if very small tributaries are considered. I mean, but the major part of our river is 1,200 kilometers. So that's it. These are small tributaries, and most part of it is agriculture. It's an area where they practice a lot of irrigation. You can see in the map that you see a lot of farming. Yeah, there are also residential areas, but it's just a farming area. You see, it's a commercial farm type, I think. So this is the area where you see agriculture. There is a big dam here. It's called Vaal Dam. Yes, yeah. So it's very uh, useful catchment for South Africa. So you can see that this is Vaal, and let me See, this is Vaal. Yeah, see the difference between Tukala and this is very, very big, maybe 3 times of Tukala, 3 times bigger. So these are the rivers, tributaries, and the language you see. For example, I have this is digitized and extracted. I digitized everything and extracted it. So Vaal 1417 kilometer length. You see, there are all the name of the. You can see the name of the see the name of the rivers. But the biggest, this is Wulinge River, Vet River, Reed, Kafir, lots of river. So calculating the budget of this catchment, I mean, you see the orange is here, we can see orange. Yes, this is orange. See, this is orange river that flows from Maseru, Lesotho to South Africa, and they mix here with Vaal River, and they go together as Orange River to the western part of South Africa. So that is it. This is Vaal Catchment. Vaal Catchment. The very surprising thing I saw here is the number of airport stations. There are more than 16, 17 airport stations only in this catchment. It's just a country. I mean, this is a very, very, very big catchment. You can see here the airports. Oh, let me. These are the airport cities. You see the airport? You can see the airport. See? Christian Airport, Harmony Airport, Welcome Airport. Lot of airports. These are cities. You see airport? Let me show the airport with lesser scale maybe. So see, these are the airports. The number of airports that, see, lot of airports. That indicates how South Africa is a very, very advanced country, you see. The catchment, Vaal, beautiful catchment. I prepare curve number grid for this catchment from land use and soil type. Actually, the land use is not it's old at the same time. It's not detailed. It doesn't indicate the land that is used for residence or building for houses or cities. Water surfaces is just simply classified with agriculture and forest, so that would not be complete for analyzing or studying the curve number of the catchment. However, it is possible to delineate by hand every part of the land use, and the soil type is always, I mean, it can't be changed. So um, it is, the soil is classified according to the FAO soil classification and nomenclature. So it's okay to do to process using all those data. So this is a catchment. I just can't stop looking at this catchment. It's beautiful, see, very beautiful catchment. Yeah, so a lot of water is coming out of this catchment, and I think it's important to know the water budget of the catchment. See, South Africa is suffering from lack of water. Cape Town, I read on the news that Cape Town is suffering from lack of water. So, and when I was in South Africa, I used to they used to talk that they want to transfer water from this to Kala Basin to Vaal Basin, from here to here. So I don't know how they are progressing, but yeah, there was a plan, something like that. So I just simply did the curve number grid. This is a curve number grid of um, Vaal Catchment. So it has some curve number. I calculated the curve number. I process it normally just similar like Tugala, but because this one is bigger, so it needs some more. Okay, it's the land use. Okay, maybe it's not here. It is. Where is that? Yes, I think it is land use val. Maybe here land use soil val. It must be here land use body land use. This one. So this one is a processed curve number or something like that. Yeah, I processed it and calculated the curve number. Can see. This is the curve number. This is the curve number. Yeah, more or less, just simply to run the model, but the land use needs to be revised and checked, and everything has to be perfect. So, I mean, this one is not complete in my view, the data that I have, but it's possible to run the model using the data available. So this is the curve number grid. After the curve number grid, then I processed the data for using the hydro tools and GeoHMS tool, and that's it. Then I found the result. This is yeah, These are a detail of the rivers, the length and so on. And that's all. That's all. So from this, I created or developed a curve number grid. Then I use that curve number grid to develop this one, to process this one. The same this catchment basin delineation. You see, all I processed this, and finally I came up with a file that can be run in HMS. Yeah, this is a schematic representation of the river, the storage reservoir, sink, and so on. So this is the outlet of Vaal, and these are the catchment. It's a very big catchment. We can see the area actually, how much is the area of the, you can see here, it's 254,000 square kilometers. I don't know how much that is correct, but it is. It's a very, very big catchment, 254. It's very big. It's very big. 254,000. So that is it. So finally, after that, I just brought it here and got some results. You see, it's not important whether the result is correct or not, but I am able to run it. You see, I am able to run it and found some results with some rainfall. I used some rainfall and just discharge and something like that. It's not the rainfall is not exactly the data from Vaal or Pumulanga or something like that. It's just simply number, I can't say. So anyway, I was able to run and get some results. You see, these are the results flow in cubic feet per second. You can see these are the results. So that's all. That's all. It is possible to run the model for HMS model for Vaal. Not only Vaal, it's also possible to run the model in other catchments. In other catchments of South Africa. South Africa is a very big country. So it's wonderful. It was wonderful for me. It shows me the possibility of just using the model and then calculating the water budget of the catchment, the system. Knowing is very important for design and planning, etc. So that's it. This is just simply a brief explanation because I have done it for Tukala. To do it also, or simply to show the possibility of doing it in a bigger catchment like Vaal as well. So that's it. Okay, the next will be in Geneva catchment. So thank you for listening. Bye. Merci.